Hi, I wanted to make a video about Ruby fundamentals, primarily for review purposes for myself. So first thing first, Ruby was made by Yukihiro Matsumoto to make his goal was to make a language that is friendly to the developers and like they enjoy making it, enjoy coding with it. So what I wanted to do was I wanted to excuse me. So I wanted to make it a calculator app. Like it's like one of those simple apps that we could do, and then maybe like go break it down while I'm doing it. So in order for us to make the calculator, first we need to welcome the user, receive input, check whether the user needs like what operation they need to do, and then basically process like the whole. If they need to add, then we'll do this type of logic. So first thing first, we'll have our starting function. So first we can welcome the user. In Ruby, we test files using the Ruby keyword and the file name. And that's all it does. It welcomes to the calculator. So then afterwards, we need to accept input, like ask for input and receive it. So we could say but you know what, better yet, we can say and so this would just print a statement asking for their input. And then now we need a variable that will save their input. Okay, so one of the key things obviously in programming is like functional programming, where like well, it's actually no, it's class programming. But so like what I'm doing right now is uh, making a function that will hold the responsibility of welcoming the user, and this is how you call a function. So when I run this file, it will hit over here, then it will go through. First it will print this line, then it will print this line, and then it will accept gets is a keyword. It's what it does is it'll it'll wait on this line until the user gives an input, and then .chomp will delete extra spaces on that input, and then it will save to the variable operation. In Ruby, you don't need a like a keyword before the identifier, like the name of the variable to declare the variable. Like in JavaScript, you have const and let. You don't need to do that in Ruby. Ruby does that under the hood. So now we can um, we can log it so we know we're receiving it. So now it's just going to wait. So I could just be like, I could do nothing and it'll stay there. And then I pick something and then it console logs what I picked. Okay, so next up, we need to know what numbers you're going to use. So let's ask for their input on the numbers. I forgot puts. Alright, so now, uh, so this will ask them for their first number, and then like we did before, we can save this to a variable, and then we can repeat this again. Never write what you can copy paste. Okay, so same thing, it'll ask for the first number, save it, make sure there's nothing extra, ask for the second number, save it, make sure there's nothing extra there. So now let's run this again. Wait, I forgot to log it. Logging is a proactive way to make sure, like, to avoid bugs. Bugs are never avoid like completely avoidable, but you have a less of a chance to hit bugs if you log everything and make sure it's working beforehand, rather than trying to fix some after, like you have 100 line function to see where the line is, where like code breaks. It's harder than doing it right now when it's like small and it's like manageable. So now we have the first number, second number, and the operation we need to do. So now what we can do is we can have a if statement. That what it can do is it'll so we did these two parts already, like the first two in our pseudocode. Um, so now we need to check, like programmatically check and direct user based on whatever the operation they decided to do. So what we could do is um, we could make a function that, so there are multiple ways to do it. Initially, I'm going to try to do everything in one function, and then maybe later on try to put it into other functions. So normally what I would do is, so if they chose add, then we can console log the first and the second number. First number plus the second number. Alright, and let's end this over here, and we can test it. Add, we have 12. This is one of the things. It's funny because so what the issue here is, since Ruby automatically decides what is um what the type of the variable is, it saved it as string. So when I did plus on it, it thought I was concatenating two strings, and it just combined them. It didn't really add them. To change that, what we could do is we could just do 2i, and we have a result. Okay, and then now we can do the same thing for the other ones. That is, if you do like opera equals, No, we just change this to subtract. Wait, no, this should be else if. And then we just keep on going for all of them. So this is how an if statement is done. If condition, you don't need any like a curly bracket or anything. You just puts like whatever you want inside of it. So like there's the if statement, the condition, and whatever you want in the condition. So you could say whatever code you want to run for that condition, you can just put inside. For convention, we put it like we just tab once, because if all of them look like this, and then you had to look at the code and try to figure out at 12 o'clock in the night, it would not be a very fun experience, especially when it gets like a lot of code. Then it'll all look confusing, and like it's hard to differentiate what's happening where. But okay, so now we do multiply. We have now we're just multiplying. Now we're doing the multiplication. And there's one important thing we always have to consider in programming is what if what if somebody gives the wrong input, or like what if somebody does something that it causes our app to break. It's always good to try to cover edge cases. So for our edge case issue would be like, we told them what they could do. They could add, subtract, divide, or multiply. But what if they decide to do something else? So then what we do is we put an else here, saying if it does not match any of these four, then what they can do is um, they could send them back up to the function. So to say wrong operation chosen. This isn't a good idea to do it this late into the function. Like you normally would want to do it somewhere up here, but we'll worry about that in refactoring. Wrong operation chosen, and we could just call on the function again. So let's test that out. So now we want to add 1, 2. It's still good, but let's test our other function out. If I just write my name, it'll still ask me for the number, which is bad, but it redirected me again to the beginning of the function and lets me choose again because I chose the wrong one. And you could just hit Control C and it'll end the code, like it will stop running the code. So now we at this point you could stop. We kind of have the whole. That's all you need to do a calculator. But for refactoring purposes, what we could do is first we could. Oh yeah, another edge case we could cover is somebody does add with the capital letters. It'll go through, but it will break. Like it won't accept that as addition. It'll send us back to the beginning. It'll fall into our other case, because obviously it's case sensitive. When we do matching, it matches the exact string. Like operation is actually like the string that they put in, so it'll match those two exactly. If there's even a minor difference, it's not considered equal. So for refactoring purposes, what we could do is we could have we can move this whole logic into a function. So we could do like operation, and it takes in the two numbers, right? So let's call it num1, num1, num2, and operation. Always remember to put the end in first. I had to learn the hard way, because eventually when the code gets huge and you have like 5 ends, you start losing track of what end goes where. So if you start putting end as soon as you start needing it, like when you start a function or you start a if loop, like like a if else conditional statements or like a loop, then it's easier that way. So what we can do is right here we could call that operation function that will take in those for us, and yeah. So whatever we call here, it doesn't matter. Like inside, like over here, it has to match the value we're putting in. It does, but it doesn't have to. This like this number, like this name right here, does not have to match this name. The order matters though. If I put in second, like if I put operation first, num1 will become operation. And now we can put in this whole logic in here. So this will take care of like doing the operation. Oh, I forgot the S. This will take care of doing the operation, and this will do the welcoming. Maybe I shouldn't rename this welcome. It's more appropriate. One of the biggest thing is naming. It's one of the biggest thing to get into. But when you start naming stuff right, it helps a lot. So, and for making sure that cover our we cover our cases, is what we could do is we could have here we can make sure it matches over here, and there's definitely better ways to do this, but for just simplicity's sake, I'm just gonna do it right here. Operation. Actually, if operation does not equal add, subtract, or divide or multiply, then we could just we can just send it back over here. So rather than like checking all the way down after they've already said their number and everything, we could just check up here. But you know what? Actually, there's a better way. We can just let them pick a number. For Alright, and what we can do is we can check for the type of. That's how you check what the operation is. So we can say if operation is not, if the operation is not integer, we can run this again. Yeah, see, I was about to forget the end. Equals, and we can just call the function again, so it will rerun. Okay, let's. Okay, let's run this again to make sure I haven't really broken anything. Okay, let's see, 2. Okay, so alright, that makes sense. Yeah, I thought I could slap chomp on, but I can't. So 2i, like I think I mentioned before, 2i is like takes the input and turns it into an integer. So like it makes sure the operation will be an integer then, because I'm just explicitly stating that. No. Oh God. All right then. You know what? That was a stretch anyway. I think we got this. I believe. Okay. So I put it 1 and then first number, second number. Yeah. One thing we're always gonna realize is error is your friend. When I went to JavaScript and like I wouldn't get like good errors, it gets very very frustrating. So errors make you a better, like they help you out a lot. Okay, so it went back to wrong operation chosen. Oh yeah, I forgot to change this to that. Yeah, this might give me an issue. Oh, but the thing is, we don't need this now because we covered our base by checking up, like just letting them have 1, 2, or 3 or 4. Okay, so now what we can do is run this again. So let's do subtraction, and first number I want to work with is 5. Second I want to do is 2. Oh yeah, funny thing, forgot that we should have returned this. So what we could do is do this syntax means run this function with these 3 values, and the return value of this function, log it. And then what we have to do is we have to actually return all this. Wait, let's do Command D, just selects. Command D selects all instances of that same thing. So if I have like 100, I don't know, dogs, if I press Command D on the first one, like if I keep it pressed, it will select all the dogs for me. And then I could just edit all of them rather than me clicking every single one of them and then changing and then clicking another. Okay, so this should work now. Choose subtraction again. 5 my first number, 2 is my second number, and it's breaking. Good. Okay, operations. One of the biggest joys of programming is when stuff starts breaking around you, like, and then it finally works. That joy is what got me hooked in the first place. Okay, now I'm console logging everything, which I should have done in the first place. So just to make sure like everything's working the way I think. A lot of times you feel like, hey, I don't need to console log this. It's obvious. This is exactly how it's going to work. But It's surprising when stuff like starts breaking, you don't even realize it. So now it's returning empty. So let me just make both of them an integer. Mm, Interesting. Okay, so the steps, I was actually gonna go break the code later and then try to fix it, but hey, it's good that it broke. So now I can talk about debugging. So the steps to debugging is to go from like one from the beginning till the end, and just like if you have no clue, because I have no clue why this is breaking right now. It's like yeah. So we start from the beginning and go all the way till the end. So first we're gonna log all the values that we receive from the user. Okay, so we log it, but still having an issue. But I'm thinking it's because that one's above the other one. Let's see if I'm right about that. And no, I'm not. It's not because of that. Okay, now we can just console log puts to see if the function is working right. Like if this function is being hit properly. Did I spell this right? I think I did. All right, now. Oh, okay. I just saw this. I called it num1 here. I called it first number here, and there's no first number in this scope. So I'm just gonna wait. No, just do the same thing again. Actually, I can just call. This will be easier if I just change this to that. An operation is good. So now it should work. And it's still breaking. Okay, good. So back to the debugging. We checked each of the values and they don't seem to be they seem to be they seem to be going fine. So we can see if our function's being hit. Alright, let's run this again. Okay, so our function's being hit. So it might be because of the fact that we don't have a like if statements like a block of code. So we have a return from this block, but we don't have a return from the whole function because this is expecting a return of like whatever the function returns. That's what it does. I'm just gonna make our life easy and put like a variable. Just just so like it's not empty. And rather than trying to return from directly from the if statement, I'm just gonna save it to the variable. And over here, I can just Ruby has implicit return, so me doing this or me doing this is the same. Ruby automatically will return the last line of the code. Once, what I did was I was running like a function, and after that, uh, I had this random block string of code, and I kept seeing this string this string repeatedly in the terminal, and then I was just curious where it's coming from, but then I later found out that it was the string that was all the way down. Okay, so this should work. Alright, I want to subtract 5 with 2, and it's not clearly not working. So back to this again. Again, did clearly not covered it right. It should have been the numbers. So for addition, we chose 1. And for subtraction, we chose 2. For division, we chose 3. And for division, we chose 4. And for multiplication, we chose 3. Alright, let's run this. At least we get to see our the input we received from the function. So now let's run this again. I want to subtract 10, like 5 from 10, and the answer is 5. And I should, yeah, I'm gonna make like another statement here. Like I want to log another thing to make sure it looks different. There's this thing called system.clear. What it does is, like it's it like I said, clears the system. I think it's I forget whether it's with a capital S or a lowercase s. We'll find out. Okay, let's run this again. Okay, I'm gonna subtract 10. No, I want to subtract 5 from 10. The answer is 5. It just clears the screen for you, so it looks more decent when you're doing programming in the terminal. Otherwise, it starts getting crowded and looks weird. So this will people. I start losing track of that. That's why I like this. System clears the whole page for me after a certain bit of code, and that's that. That's the whole. That's the calculator refactored. What we could also do is we could make a class out of all of them. So we could just do, but that's just gonna be too much. I'll probably do that later in another video. Alright, this seems like a pretty good recording. Thank you. Goodbye.